Hello, everyone. I'm David Cabanas. I'm running the EMEA sales operations for operators. First of all, thank you for joining the webinar. Today on this webinar, what we will do is explain and clarify all the aspects related to the Cel-Fi SOLO installation process. For your information, the Cel-Fi SOLO was launched about 1.5 years ago. It was a new product, new concept after the successful launch of other Cel-Fi devices like the Go, Duo, Pro, or Quattro. And it's true that since we launched it, we managed to make a successful transition from the purely plug and play use case that we had in previous products like the Duo and the Pro to this new type of installation with the Solo. You will see that the Solo is a single box product that has a lot of very nice features, remote management, 5 bands on it, and it's a really powerful product. So my colleague Andrew Williams, who runs the technical support around EMEA, he's the solutions architect supporting most of the operators around, will do this presentation. So again, thank you very much. Please don't hesitate to tell us if you have any question or any doubt or any issue seeing the presentation. I pass to Andrew so he can start the webinar.
Yeah, very good. So I am Andrew Williams, as it says on the screen. I'm based in our European office, which is in Swindon in the southwest of England. So you're attending the call with us today, and I'm sure you're aware here poor mobile coverage is a fact of life today. Right? So there are many reasons for this, including basic physics, but one of the real drivers today for all causes of problems is actually modern building construction, because modern building techniques, foil-backed insulation, modern insulation materials, low E glass, thermally reflective glass, right? These are all things that make it hard for RF signals to penetrate buildings. On the other hand, mobile coverage is increasingly important, in life and in business. And testament to that is the year-on-year decrease in landlines for businesses. So every year the number of landline minutes consumed by businesses drops, and will continue to drop as mobiles become the default communication mechanism. So what is a smart signal booster or intelligent RF repeater? Well, firstly, for those who really aren't aware, a signal booster or an RF repeater is a device which takes RF radio frequency signals, mobile network signals, from one place and sends it somewhere else, and it typically amplifies it along the way. So here you see a picture of a tower. So there's several parts typically to a signal booster or RF repeater, right? And we'll refer to these terms during the presentation, so I think it's good to describe them now. So the first one is the donor antenna. So the donor antenna is where you get the signal from the mobile network, sometimes referred to as a pickup antenna, and other terms. So it might be placed outside a building, could be placed inside a building. We have the RF repeater itself. So this is a piece of electronics that can take RF signals, amplify them, pick which ones it wants to relay, various things that it does. There is cabling of some kind, and then there's a server antenna. So the server antenna is the antenna inside the building that provides the service and lights up the building from the inside. And then if you have a mobile device and it's talking to the network, then the path is reversed, where it comes through the server antenna, through the RF repeater, out the donor antenna, back to the network. So that's the basic technology. That's the terminology that we will use for the rest of the webinar. So what's Cel-Fi, and what is it? Who are we? What do we do? So it's a set of technologies that really make us almost unique in the market for how we can do these things. Right? So the heart of what we do is a chipset and a system on chip. In fact, more than one chip. In fact, that we make. But the heart of our chip is called IntelliBoost. The products we're telling you about today, based on the 3rd generation chip, we already have a 4th generation chip. Right? So we've been doing this for over a decade. So it's completely owned by us. We have all the intellectual property. It's made in a Toshiba chip fab, but we effectively are a fabless chip manufacturer, and that's what we make. In addition to that, the vast majority of the software in our system is written and owned by us. So we are experts in embedded software and how to port radios for many bands close together for products like this. So again, it's a difficult problem and something we have over the last decade really learned to specialize in and do well. We have a number of antenna products, and we'll tell you a little bit about some of those later in the presentation. Obviously, we have our mechanical design for the various types of products we have, and then other things that then wrap this up. So we have tools that are for various issues to do with installing and how to use our product and looking at that. We have apps. A lot of you may be aware of our Wave mobile app that talks to all our current generation of devices. And then we also have cloud software and cloud-based management. And these all fit together to make what are Cel-Fi products. So let's talk a little bit about the Solo. And this is really the heart of the presentation now. So the Solo is, as David said at the beginning, a single box signal booster, single box repeater. It has many unique features. But, one of the things that it can do and all our products can do is it's capable of 100 dB of system gain. So system gain is a measure of how much you can amplify the signal, and 100 dB is exceptional for kind of this class of device and this size of device. And we make the claim it's the highest performing, and that's the main reason why. Not only that, it can do it safely. So it can do 100 dB of system gain. It won't always do 100 dB of system gain. And we'll talk more about this later, but the device is aware of its environment. And because it's aware of its environment, it can adapt what it does to where it is. So let's have a little look at spectrum. Radio spectrum is important, and as I'm sure many people here are aware, mobile networks do not just use one piece of spectrum, they use many pieces of spectrum. So in this presentation, we'll refer to bands and band numbers. So let me just go through them now for anyone that needs a clarification. So we have band 1, which is also known as the 2100 megahertz band. That was the original 3G band and is currently used for 3G and 4G. We have band 3, which is otherwise known as the 1800 megahertz band. That was originally used for 2G and now is largely used for 4G. We have band 7, which is the 2600 megahertz band or 2.6 gigahertz band, largely currently used for 4G. It was originally deployed for 4G and still largely used for 4G. We have band 8, which is also known as the 900 megahertz band. So this is the original 2G GSM band, and it's currently used for 2G, 3G, and 4G. And then we have band 20, which is the 800 megahertz band. So this is the digital dividend spectrum from turning off analog TV signals across Europe, and that's currently used for 4G. We also, in our products, we make a differentiation between high bands and low bands. So high bands are anything above 1 gigahertz or 1000 megahertz. So that's bands 1, 3, and 7. And then the low bands are anything below 1 gigahertz or 1000 megahertz. So that's bands 8 and 20. Now let's have a little look in some more detail at the Solo. So it says here, for applications requiring mobile network indoor coverage improvement. As it says there, it supports 3G and 4G. So that's WCDMA, HSPA, HSPA Plus, 3G, and 4G LTE. It can support up to 100 dB gain. It has 5 RF front ends, which can support bands 1, 3, 7, 8, and 20, the bands we described. And it has 3 radios. Each radio is 20 megahertz wide, and it can support 1 band and technology combination per radio. These may only be 5 megahertz, maybe 10, maybe 15, or maybe 20 for any given radio. And that it depends on the environment in which you deploy it. It can relay various combinations of bands. It's capable of relaying 2 radios on band 1 for the case where you have 3G and 4G in different spectrum in band 1. One radio can do that, or 3G, one radio does the 4G. It can relay 2 low bands and 1 high band. It can relay 2 high bands and 1 low band, and it can relay 3 high bands. So there are a few combinations of bands it can't support, but in general, it supports almost all combinations of bands deployed in networks. It has SMA RF connections on the donor and the server ports on top of the device, and we'll show you those in more detail later. It has an option for an internal modem for remote management. So that's the basic hardware. So in terms of the benefits of the device, well, as is the case with all our devices, it's unconditionally network safe. So this is a big claim that we make, and it means several things, right? So firstly, it's capable of being fully automatic in the settings of the bands and the channel bandwidth and the gain. So for instance, the system, it reads the broadcast channel of the network in the bands that we're talking about, and it will automatically set the channel bandwidth based on the broadcast parameters. The gain is automatically set by a number of parameters, the most prominent of which is how close it is to the base station. So these devices can read the broadcast channel, they can read the pilot transmit power, they can measure the pilot receive power, they know the path loss in the downlink, and make decisions based on that in terms of how much gain will set and to limit the noise that they will insert into the base station at any point.
Yes, Andrew, some questions
Sure.
for you. There is a question that asks why we decided to launch the Cel-Fi SOLO when we have the Cel-Fi Go. He says that he doesn't understand all the difference. I think that they feel that it's worth mentioning.
That's very good. So that's a very good question. So in some ways, the Go and the Solo are similar, and in some ways they are quite different. So they are similar because they have the same set of front ends. So the Go and the Solo can support bands 1, 3, 7, 8, and 20. The Go has only 2 radios, and the Solo has 3. Right? So the Solo can relay more spectrum than the Go. There is a limitation for the Go in that the Go cannot relay 2 low bands. So it's a limitation of the hardware of the Go. So it cannot do band 8 and 20. So the Go is not capable of doing 900 and 800 channels together, but the Solo is. And that's probably the biggest limitation of the Go, and something that the Solo can do that the Go cannot. And the final one is that the Go is designed for harsh environments, actually. So it is IP66. So you can mount it outdoors and use it in harsh environments, whereas the Solo, you cannot. It's IP20. So the Solo can only be used in an indoor environment, or if it's outdoors, it must be placed in a cabinet.
I should add to Andrew, if you allow me, that on the test that we have done, the Solo is much more powerful, boosting and amplifying the signal. And of course, this what you just said, the internal modem that the Solo has for remote management. There is also a big difference with
very powerful. Yes, and there is one more thing actually, David. I forgot to mention. Right, the Solo has more downlink power than the Go. Right, so the Go is limited to 16 dBm in the downlink. The Solo is capable of doing 20 dBm, and it's just on the bottom of the slide here. So, the Solo has 4 dB more power in the downlink. So, and the idea is that it makes the Solo better capable of driving, longer cable runs on the server side, or driving multiple antennas or passive DAS on the server side. Right. So that's also a big advantage of the Solo.
Thank you, Andrew. There is another question about the bands, if the bands are pre-configured, and if there is a way to configure the bands that the Solo uses, like 2 high bands, 1800, 2100, and 1 low band, 800, or it's all automatic?
So it's a good question, right? So firstly, we work with the mobile networks to determine a profile for the network. So the device must know the PLMN ID of the network it belongs to, which is the mobile country code, mobile network code, because the Solos basically only work on one network at a time. Then it does have an automatic algorithm that it uses. So it takes the profile, it actually takes information that's broadcast about the neighbor frequencies by the location it's at. So it can read the neighbor lists of the cells it can see and make decisions then on what it will relay. So it will make a default decision. It's normally based on the camping priority of the network. So the networks normally prioritize high bands. But it will follow the camping priority of the network for what it boosts. Then you can override it. Right? So by default, for instance, it may choose band 1, 3, and 7, but you want it to boost band 1, 3, and 8, you have the option via the mobile app to override the band selection that it's made and just turn off one of the bands so that it will use a different one. For the remotely controlled version with the modem, you also have the option to remotely control the automatic band selection and again override it through our web-based management system. There's one other parameter which we normally include in the profile, and that is we can set it so that regardless of the camping priority broadcast by the network, we can force the system to relay 3G. So, and that's quite useful in many networks currently. Right? So there are many networks where we have that profile option set. So for instance, even if the top 3 camping priority sort of channels were all 4G, we can force it to then relay a 3G one, drop one of the 4G ones and relay 3G one automatically. So it would do that automatically. And then you also have the option to further override it if you want to.
Okay, thanks. And a final question for this first set. Another attendee is asking if the Solo is multi-carrier.
It's not as in any of the configurations we currently build. It's a single operator configuration, and the majority of the products that we have, all the products we currently sell in EMEA, except in some very, very limited circumstances, are single operator products. Of course, you can make multi-operator by putting 2 of them next to each other, right? So, and that is commonly done. So if you want to cover 2 networks, you can put 2 in. You want to cover 3 networks, you can put 3 in. They're not very big. The cabling's fairly straightforward to do that if you want to do that.
Excellent. Thank you very much, Andrew.
So going through, following up on the discussion we just had, as it says here, the Solo knows the PLM NID of the network it's configured to, right? And it will, as we discussed, it has a profile of frequencies. It also reads broadcast information from the network, which it can then find additional frequencies and use the algorithm it has, which follows the camping priority broadcast by the network to select what it's going to map onto its 3 radios. Here's some typical combinations that you might have, for instance. And the one that you definitely see with the Solo in rural areas, and you cannot do with the Go, is band 8 3G, say, and band 20 4G. So you've got the 900 3G and the 800 4G. And so the Solo can and will do that in a rural area. The Go, unfortunately, cannot do that. We have a set of antennas and cables. I've got some more slides on that later, so I won't tell you about those now. So let's take a closer look at the hardware. So we mentioned there is an option for a modem. So there's 2 hardware versions, and they look like this. So they are in the same case. It's a cube. It weighs fairly heavy, weighs a couple of kilograms. It's got some fairly substantial metal heat sinks inside it. The donor port and the server port are on the back. It has a status LED on the front, which can be red or green and flashing or solid. And then in the case of the one with the modem, it has a special modem port on the front, and we'll talk some more about that in a moment. You'll see models with a modem have a C in them, in the model number and the part number, and that refers to cellular modem. And the versions that do not have a modem have a B in the model number and the part number, and that B stands for Bluetooth only. So both of these devices have Bluetooth, and both of them work with our mobile app. So let's look in a bit more detail about the modem. So if you order the modem version, then you get an integrated category 1 modem. So it's not a particularly high performance modem because it doesn't need to be, but it's optimized for machine-to-machine and Internet of Things applications. Right? So our management model is really like an Internet of Things management model. So it supports all the LTE bands that we like to see, all the 4G bands and the 3G bands we like to see in the region. Has those certifications, and it has a 3rd antenna port at the front. So briefly, I mentioned it on the last slide. So the modem has its own port. So you must somehow provide a signal into that port so that the modem can work. So how do you do that? Well, there's several ways you may choose to do that. Right. So one way is you can do this with some kind of RF power splitter, divider, RF tapper on the donor antenna. Right, so there's some advantages to this. It means that the system is manageable, whether it's boosting the frequency the modem's using or not. etc., etc. So you can do that. The downside is, of course, you tap off some power from the donor antenna. You could give the modem its own antenna, right? So that's possible to do. You can directly connect a whip antenna on the port, and the kits that we'll describe later, they have an antenna that come with the kit for that purpose. There are a few places, where, for instance, you may be installing the Solo right in the basement of a building where there's no coverage even with the boosters on, where you have to then give the modem its own antenna, away from the device, being the coverage of the server antenna somewhere in the building. So that's kind of extreme one. We occasionally have seen those in the field also. So with the modem option, the base of the unit looks slightly different. It has a little recess with a port for a nano SIM to be inserted, and a little picture of a SIM card to show you where the corner of the SIM card goes when you're inserting it. Then, in terms of setting the SIM card parameters, you use our mobile app for that. So we have a SIM toolkit, but it doesn't always recognize the network that the SIM card is for. So in the majority of cases, you will need to enter the parameters for setting up the data connection to the SIM card. So that typically means the APN. So you'll have the APN name. You may have a username or not. You may have a password or not, depending on the network setup. And those things are usually clear. The networks obviously know what they are. If you're a third-party installer, these things are easy to find on the mobile network websites. If you live in a country where it's common to have PIN settings on SIM cards to protect them, then you can enter the PIN information also via the mobile app. So that's it for the modem. I will now move on to some information about how you go about installing it. So here's an example of a building with poor indoor coverage. It's got good signal outside. It has modern insulation, thermally reflective glass. You've got a little bit of signal by reception area, say, and nothing inside the building. So what do we have to do? Well, first we've got to determine where we're going to put the donor antenna. So remember, the donor antenna is the thing that picks up the signal from the mobile network. So we have to determine the donor antenna location. We then have a look at the building, see where we can run cables if we want to, where we're going to mount the device, where we're going to put the server antenna. So kind of those are the things that you do, and these are true whatever you do, however that goes, whatever device you're using. Typically, those are the steps you need to go through. So we have some kits for our devices, and these are bundles that come with the device. We'll talk about them later in the next few slides. But there's kind of three main scenarios. There are a few more, but the three main scenarios you can do with our kit bundles are putting the donor and the server antennas inside. And if you're doing that, typically you'll directly connect the donor antenna, put it on top of the unit. So you've got the whip antenna, just screw it directly on the donor port and place the device where it sees some signal. You might put the donor antenna outside and then put the server antenna directly on top of the unit. Right. So again, that's screwing the whip antenna on the server port this time. And then you may put the donor antenna outside and away from the device, and the server antenna inside away from the device. And we supply kits of parts that allow you to do all of these options. Right, there are various kits that I will describe in the next few slides. But in addition to that, of course, if you're not using our kits, there you can use other cables, other antennas. And via the end of the presentation, we'll talk a bit more about that. So here's scenario one. So, typically give you a few hundred square meters of coverage. So, you typically will place or mount the Solo unit where it can see an outside signal source. It may well be near a window. It may actually be away from a window where you still see some signal, and attach the whip antenna to the donor port of the Solo. So the donor port has a little picture of a mobile network tower, like that picture there. You then attach the coaxial cable to the server port, which has a picture of a phone, and then run the cable and place the server antenna far away as possible from the Solo unit towards where you want the coverage. Plug the device on, and it will come up, scan the network, decide what it's going to boost, and then start relaying the signal. So there's another scenario. Here we mount the donor antenna outside the building where we can get a good signal and run the coax into the building. So in the simplest case, we find a window that has compressible rubber seals and opens. In that case, it's fairly straightforward to mount the antenna outside. Run the cable through the window with the rubber seals that you can compress without damaging the cable. Close the window and bring the cable into the building. If you can't do that, you've got to find another way to penetrate the building, which may involve getting a drill out, making a hole in the side of the building or a window frame or however to get the cable in. Then place or mount the Solo in reach of the other end of that cable, and then attach the whip antenna to the server port. Plug it in, turn on the power. Typically we talk about this giving you 1,000 square meters type coverage.
Andrew, before you move on, there are some questions, several of them, asking about what's the maximum distance between the donor antenna and the Solo, and the same for the server side. So I assume that it depends on the type of cables, but we are offering different type of cables to reach more distance, isn't it?
Yeah, it exactly depends. It depends really on two things. It depends on how good the signal is outside, and how good the cable is. Right, so that's basically true. Yeah, but in terms of both our kits and in general, right, we've got a lot more materials on that later in the presentation. So maybe we can discuss that a bit more then. But it's fairly simple maths to do that. Now this presentation really just covers the kits. We maybe should do another webinar later where you can go through how we do the calculations. But let's talk about the kits, and then maybe we have a little bit more discussion about that later. But essentially, the thicker and more expensive the cable, the lower the loss it has. That's kind of the way to look at it. So scenario 3, right? So again, this is where we mount the donor antenna outside. We run a cable into the building, so either through an opening window with compressible rubber seals, or otherwise some other way to penetrate the building from the outside. We put the Solo then inside the building, and then run the second cable to the server antenna inside the building. So I plug in the system, turn on the power. So just to help a little bit more with what we've just described, if you look at the back of the device, it has a picture of the mobile phone network tower, which is the donor port, and a picture of a mobile phone, which is the server port. If you buy our kits, right, they come with double-sided tape and cleaning pads and all these things. So you can, for instance, clean the frame of a window, attach double-sided tape and stick the donor antenna outside on a window frame. And this shows you that. We can run it through into a window that has a compressible rubber seal, as you can see there, and close the window, and it will not damage the cable because you've got several millimeters of compression within the rubber seal. And so that generally works very well. In terms of the server side, you can see there's one of the pieces of double-sided tape that we supply with the kits, and then the server antenna mounted. So what we tend to do is, if the donor antenna is vertical, we tend to put the server antenna horizontal, and that's a deliberate decision to change the polarity of the way they work, because they're polarized in a certain direction, so you can improve the isolation by having them opposite polarities, so one vertical, one horizontal. Then after we've done all of that, turned it on, you use our mobile app, and it will give you an indication of the health of the system. So two main parts here I'll focus on. So I'm not going to tell you about the app in detail today, but that's something we might be able to do in a future webinar. But you come to run the app, first thing it shows you is the dashboard. So you see the network it's on, you see an overall summary of how the installation is running. So you'll see a signal strength indicator, a signal quality indicator, and a boost indicator. Right. So the boost indicator is largely around how much the system is able to amplify the signal, mainly surrounding how good the isolation is between the donor and the server, and some of the factors. And then signal strength and signal quality. Now, the system has 3 radios. On the dashboard, you just see a summary. It's kind of biased towards the best. But then if you go to the advanced part, you see 3 radios: Radio A, Radio B, Radio C. So here's a case of a system that we had. So it was running band 1 3G on one radio. It was running band 1 4G on Radio B, and then band 3 4G on Radio C. That's 2 band 1s and a band 3, and you can see there the measurements for the individual bands. So that's how you do the check after you've set the system up. So as you buy the system, there are base kit options. So you can just buy the individual device. It comes with a set of 3 kit options, and then there are some additional kits that come with more cables and antennas. So the base kits, there's 3 of them, and then we have 2 versions of the hardware. So we have the modem version of the hardware, and for the model we're talking about here, that's the H419C, and then we have the Bluetooth only version, which is the H419B. Right. So the number 9 refers to the band combination 1, 3, 7, 8, and 20. Right. So for each of those, we have a variant 001, 002, and 003. So 001 is if you all things being equal, that's the default you'll get. Right. So that has the patch antenna with an 8-meter cable and a single whip antenna. That's the 001 option. We have the 002 option, which has the 1-meter patch antenna and whip antenna, and the idea is there that you're going to use your own cable in between the device and the whip and the patch antenna with a 1-meter cable. And then we have the 003 option, which has no antennas at all. It's just the bare device and power supply. So in terms of what they look like, right, they come in a box like that. Which has the Solo at the top and then all the other parts underneath. So you open the box up, there's a quick start guide in the box. And then the contents of the box, as it shows you there, right? So there's the whip antenna with the 8-meter cable in the case of the 001 option. There's a mounting bracket and screws, power supply, and then the whip antenna. And then obviously the Solo device itself. If you look at the 003 option, right? So that has no antennas, comes in the same box. You get the same power supply, same bracket, same screws, same Solo, but with no antennas at all. So that's the 003 option. Okay, so there are kind of base kits. We then have a number of kits where, these are what we call often referred to as our professional bundles, and that's what David will talk to them about. So for those, we have obviously the 2 variants of the hardware. We have the modem version and the Bluetooth only version. And then we have 3 grades of cable that are available. So we have RG58 equivalent cable with a 20 meter and a 10 meter cable. We have a LMR 195 equivalent cable with a 10 meter and 20 meter cable, and we have a LMR 240 equivalent cable, which is a 10 meter and 20 meters. We have either one patch antenna or we do have either one patch antenna or 2 patch antennas, depending on the option, and we have either 1 whip antenna or 2 whip antennas, depending on the option. So this comes down to cost, right? So in quality, so RG58 is the least expensive cable, but it has a higher loss in the cable, and LMR 240 is the most expensive cable, and it has the lowest loss in the cable. So we have, we've provided the data sheets for these with the loss, or you can just go look them up online. But those are the options we get, and the one, LR240 offers the best potential performance. RG58 offers you the least good performance, but they all generally work well.
Just Andrew, just one comment on my side regarding that. I should say that these different bundles have been developed and defined after getting the feedback from our customers. While some system integrators and operators have decided to buy the Solo as it is without any accessory, it's true that some of them prefer to have what we call this professional bundle that includes everything. So then the installer can open the box, the package, and have all the different elements and decide what elements will use. That doesn't mean that this professional bundle, having the 10 meters and 20 meters coaxial cable and the antennas, the installer needs to use all the accessories. At the end, it's him who will decide what number or what are the accessories that he will need to deploy the Solo. But at least we give the chance to have everything on the same box and not limit the installation.
Yeah, and that's the big advantage. Then is, as you said, exactly that, David. Right? If you have the kits with both cables and all the antennas, you're fully covered for any situation, even if you don't need them in a specific one. So let's have a look at what the kit looks like. So here's a H41 9C222. Right, so these have a much bigger overpack, right? So there's an overpack, and within it, if you open it up, you see a specific bundle quick start guide. So we have a different quick start guide for the bundle. It's in addition to the one for the Quattro itself, which talks about how to use the cables and the antennas. And then you have a box, which is the normal Solo box, and then 2 other boxes containing the cables. So if you open it up, right, so here's the example. You can see there's a 20 meter for this kit, a 20 meter LMR 195 equivalent and a 10 meter LMR 195 equivalent cable. See that on the left, and on the right we have the 2 patch antennas with the 1 meter tail on them, and the whip antenna, and then the bracket mounting screws and the power supply. It's H41 KH41 9C222, so this is the modem version. So you see the modem port on the front, and by default you'd use the whip antenna on the modem port. So if you were then to use this kit, that's what it would look like. For instance, if you connect them all up, if you use all the parts. So you may not use all the parts, right? If you do use all the parts, that's typically how you would connect it up. So you have the patch antenna, the donor antenna, 10 meter cable, whip antenna on the modem port, 20 meter cable, and then the server antenna inside the building. Look at one of the other kits that we described. This is the KH41 9C111. So this gives you the 10 meter coaxial cable LMR 195 equivalents plus the patch antenna and the 1 meter tail, and 2 whip antennas. So this allows you to put the whip antenna on the server and the whip antenna on the modem, for instance. So before we move on, are there any questions anyone has on the kits, David, or shall I step on to the next part?
Yes, there is a question that I think relates with the following slide in terms of what we call the professional installation of the Solo. It's about, on the server side, how many omnidirectional antennas can be used. I should say, before you answer this one, that some of our partners have managed to connect a lot of omnidirectional antennas using a good cable. So this is one question. And second, there is another question that repeats quite often on the chat. It's about the 5G support on the Solo. I don't know if you prefer to answer the 5G question now or later, but
I think that's a very good question, and I guess we were expecting that. So I think the 5G one, let's talk about the installations, and then we'll cover the 5G at the end. I think that's a whole subject in itself, so I think that would be useful. But I'll skip over that now. But to talk about these more advanced installations, as you did, David, right? So this is where it's more involved. So with all our kits and professional bundles, as David says, these are designed, you can basically show up on site and do a very brief survey of the building and get the whole thing working in a very short amount of time. If we're talking about something that's much more professional, where you will do a site survey before you start, determine if you could put a pole on the side of the building or on the roof or wherever, and then run put a pole, add an antenna and point the base station, all these things, right? So these are all obviously possible to do, and these all work well with the Solo, and the Solo still works and still adapts to the network conditions, etc. in that way. In terms of how long a cable you can run, it just depends on the type of the cable, right? These are basic link budget calculations. So I normally advise people that you look at the cable loss at 2,000 megahertz or 2 gigahertz, right? The data sheets for the cables you have will give you a loss at various frequencies, right? So in a lot of cases, these will be relay high bands. So if you engineer the cable loss for 2,000 megahertz, that's usually a good way to do it. So you don't want to be losing 40, 50 dB in the cable if the input signal is very weak, right? So you really need to rather use much thicker cable and have a much shorter, much less loss if you have a long cable run. So these are all things that we talk about in our training that we provide. And so there's no obvious answer. The answer is it depends on the situation. So our antennas have a certain performance, the cable on the donor side will have a certain performance, etc. On the server side, then, what you can say about the Solo is if it's possible, if all other things being equal, if you don't have a poor installation, it's capable of up to 20 dBm transmit power in the downlink. Right, that's the total power. It's not the pilot power, but it's total power. But then, that does translate into quite a healthy pilot that comes out of it. So it is possible to put in, splitters. We'd have people that run passive DAS with RF tappers of various types along the length. And so all the kind of traditional engineering you can do for passive DAS definitely will work, right? With the proviso that, if you're doing that, typically you're going to be using very thick cable, right? You might be using 1/2-inch cable, LMR 600 sort of cable, if you want to extend this over any distance and still maintain the performance, right? But the Solo, because it has more downlink power, is really well suited for this type of application if you wanted to do that. And then, there's things that we can do as illustrated in the multi-unit one there. So, one example is you may cover multiple floors of a building like that and split the donor antenna. You may put multiple networks side by side and multiple donor antennas. So with that in mind, Nextivity makes a number of antennas that are all good choices to use with the Solo for the different situations that you may encounter. So I'll briefly go through them here. So we have something we have called the LPDA antenna. So this is quite a large log periodic antenna, metal, fairly large, fairly heavy. It's our highest performance antenna, particularly good if you're either in a rural area at the cell edge, or if you're in an urban area and you want to focus in on particular cells and exclude other ones because it's fairly directional. Then we have our Cel-Fi wideband directional antenna. So again, this is a smaller LPDA antenna. It has a plastic cowl, so it's pretty directional, has good performance, and is generally a bit easier to deploy than the LPDA just because it's smaller and lighter. Then we have the Cel-Fi wideband panel antenna. Right, so this is a square antenna, fair bit smaller. It has good performance, but it's generally easier to deploy than the first two for a donor antenna, just because it's smaller and square. Right, so if you're in an area where there's some sensitivity on building control or the way something looks, then sometimes that's a good antenna to use, and it's certainly easy to install and has good performance. So on the donor side, those are the antennas that we offer that work with the Solo. On the server side, we have a couple of antennas. So, in theory, you can, for instance, use a wideband panel antenna on the server side if you want, in certain circumstances, or even some of the others, but generally you wouldn't. But indoors, we have a couple of ceiling mount antennas. We have our indoor Omni antenna, shows there. We've had that for a while. We also have a newer antenna that's available now, which is the low profile indoor Omni, which you can see there. It's less than a centimeter thick, so that fits onto a ceiling tile, and a false ceiling is really unobtrusive. So for all these antennas and their specifications, the spec sheets for them, etc., you can visit our products part of our website. So that's there, and the technical information for those is all available there. So in terms of installations that don't use our kits and bundles, these are the antennas that we offer to work with that. As I mentioned, for doing this, you then need to get into looking at the cable losses, both on the donor side and the server side. And then if you're using passive RF components like splitters and tappers, you have to do the link budget work to make that work. And if you know that it's fairly easy to calculate the power involved, and then you do the sums and do it. Right, so let's talk about the 5G. So there's several parts to rolling out 5G. So firstly, the bands that the Solo supports are the bands that the Solo supports. Right, so this is bands 1, 3, 7, 8, and 20. Right, so for instance, it cannot support band 42, 43. I think, or the 3.5 gigahertz or N78 band. Right, so it's physically not capable of doing that because it doesn't have that hardware on board. And we will in course have product announcements in that space. However, there will definitely be, and is already, activity in reusing 4G spectrum or some of the existing spectrum for 5G. and that takes several forms in the current band. So there is what's called dynamic spectrum sharing, right? So dynamic spectrum sharing of a 5G resources within a 4G carrier. Essentially that will work on the current hardware with the current software as is, although we are introducing some tweaks to that should enhance the performance of that at the end of this year. But essentially that works already, or should work already. We have the ability to do 5 standalone 5G NR carriers in the existing bands. So this would be the case of, like I said, a standalone 5G carrier in band 1, 3, 7, 8, or 20. Right, so the capability to do that, we don't currently have that capability. We are updating our software to make that possible. So there is an upgrade path if either some or all of the spectrum in a band is refarmed completely to 5G NR. And then we'll have a software update in the bands that are supported by the Solar that will allow you to do that. Then the final one that I've seen, in addition to that, is kind of 3G, 4G, 5G DSS, and we're actually looking at how we'll support that at the moment. So we think that's possible, but on this existing hardware. But that's something we're looking at now, and we were in the process of testing it. So any more questions or anything else that we should cover on this then, David?
No, there are some pending questions, but Hussam is taking care of it because those are much more specifically and technical.
Excellent.
If there is a data sheet available and some other things. So I think that yes, that we are done. As I said, that some of the pending questions are going to be answered offline. I think that we managed to respond the vast majority of it. So I don't know if there is any other open question. There is still time. Okay. No, I think that people are asking about pricing and other 5G things. I think that you already answered this one. So for further questions, as I said, please reach any of us. But any of the questions that you have placed on the panel are going to be answered. So you see on this final slide, these questions at Cel-Fi.com email address. So please, for further questions, anything related to the solo, to the webinar, to potential interest, anything that hasn't been answered during this presentation, please contact us using this question.celfi.com at email address. Thank you, Andrew. Thank you very much. Thank you to all the attendees. I hope that this has been interesting for all of you. Thank you very much. And thanks, Andrew.
Thank you very much as well. Thanks.